As governments around the world call time on the internal combustion engine, many believe that if the electric dream is to become a reality, we need to not only radically change the design of our vehicles, but also how we use them, and even how and where we make them. A global technological revolution is underway.
We think in the next 10 years, you'll see more innovation than we've seen in the past 50.
Driven by passionate, dedicated individuals intent on shaping a new world.
I want to create something new. I want to create something that gives me the sense of creating new life. This is why I'm here.
A greener world.
This is the last call to action, that we have to develop the solutions that are protecting our planet.
A better world.
I have a family, and when I think about the life I want them to have and their children to have, I want them to experience the world where they can travel and live without worry, and that gets me up and going every day.
Together, they are pushing engineering to its limits.
Human creativity is the most tremendous power, and if you set a target, things that you never thought possible become possible.
Creating extraordinary machines that can help the planet and humankind in the future. If we are to stand a chance in our struggle to limit global warming, a change in the way we travel will be essential. Transportation accounts for 24% of global CO2 emissions. And in the US, that figure is 29%. The vast majority of it comes from what we drive on the road. Our relationship with the automobile has been a defining feature of modern life. But as we make the transition to electric power, many experts believe that the nature of this relationship is about to undergo a revolution. Without doubt, this presents a challenge, but it also presents the opportunity to redefine the way we travel. No stranger to thinking differently about how we use vehicles is Robin Chase, co-founder of Zipcar, one of the world's leading car share companies, and Venium, a data network company that is helping to support what's known as the Internet of Moving Things. She's worked with institutions and authorities around the world, developing innovative transport strategies.
I think of transportation as our gateway to opportunity. Whether you want to be educated, see friends, have a job, be healthy, go shopping, everything resides upon, can you get there? How much time, how much effort, how much money? It is the glue that makes our entire lives possible. So the idea that there's one type of vehicle or one type of mobility solution that will service all of our needs is craziness. And that was what happened in the last century. When people buy a car, what happens is they think about their largest use case. They think, oh, I need to have it so in August I can take my family on some big trip with everything in back. But in reality, 70% of our trips are us alone in the car. And 50% of our trips are less than 3 miles or 5 kilometers. So the reality is, it's us moving alone by ourselves for the vast majority of our trips. And cars, whether they're electric or not, are vastly oversized for what we're actually doing.
This is the Aptera, soon to be the most aerodynamic production car in history. With a potential range of 1,000 miles from a single charge, it's convinced over 15,000 customers to place an order before a single vehicle has rolled off the production line. But this is not the product of an automotive giant. This is what happens when some engineers from San Diego take an uncompromising approach to efficiency. The Aptera story started over a decade ago, when electrical engineer Steve Fambro, sitting in traffic during his daily commute, became convinced that there had to be a better alternative to existing cars. Something more efficient, and certainly something more sustainable.
So I started building this car just as a hobby. And at some point, the light went on where I thought, if I could get paid to do this, I would do this all day. So I started thinking about, well, what would that look like? What is that? Well, it's a startup car company to sell the most efficient vehicle in the world.
And then Steve met Chris Anthony, an entrepreneur who was building composite wake boats, who not only shared his passion, but was also prepared to think differently.
And it was off to the races. It was really bizarre how quickly it all happened.
Well, you know, when I first met Steve and he explained the math equation for why typical vehicles use so much energy, the first thing that he brought up was a typical Toyota Camry type vehicle will use 60% of its fuel just pushing air out of the way. And it instantly struck a chord with me because I was a hydrodynamicist and I'd done lots of simulation work and worked on how fluids work. And I said, yeah, I get it. That's a problem. And he said, I think that we can build a vehicle that takes that aerodynamic drag almost down to zero. Perfect, sign me up. Let's build that vehicle. And we didn't start with a marketing study or a focus group. We started with the engineering problem of how do you make transportation more efficient? And then we just ticked through the boxes on what would make the most efficient vehicle platform. And what you end up with is something that looks like what I have behind me.
When I first started looking at low drag shapes, I thought, well, let's look at the streamliner hot rods from the 1950s and 60s. You had a lot of veterans who returned after World War II and were taking aircraft parts and drop tanks and turning them into hot rods and then taking them to the salt flats and seeing how fast they could go. And for the amount of horsepower and the size that they were, my back of the napkin calculations said that they should have been able to achieve much higher top speeds because of the streamlined shape. What I didn't realize, and I guess maybe what they didn't realize at the time, is that a perfectly symmetrical streamlined shape has very low drag in the free stream, up high in the air. But when you bring it close to the ground, it has a completely different effect. In ground effect, it becomes a much higher drag shape. And so to make a streamlined shape, but that's also low drag and ground effect, it looks different. And as it turns out, lots of creatures, fish, catfish, sharks, etc., that swim in the free stream, when they get down near the surface, they will change their body shape to lower their drag. And the reason they lower their drag is because nature hates inefficiency. Nature doesn't do anything inefficient. It's all about saving energy.
So sharks really taught us a lot about how things work in ground effect. So that's why the Aptera looks a lot like a fish or a shark swimming close to the seafloor with a hump on its back.
Before we went out fundraising, we said we need to have some third-party seal of approval. Who could we get to also examine this shape, maybe put it in their wind tunnel, give us a thumbs up that it is low drag. And so we hired NASA Langley low-speed wind tunnel. And we had a conference call with them, and you could hear all the scientists on the conference call. They're like, this is the lowest drag road vehicle we've ever seen. Like, what are you guys doing? How does this work? And we said, we hired you to tell us how it works. You're NASA.
What has enabled the team to fine-tune their design in a way that would have been impossible a decade ago are the advances in computational fluid dynamics. This is a computer tool that can accurately analyze complicated aerodynamics and airflows.
We bought a lot of servers. This is after we got our funding, and we ran CFD 24 hours a day for virtually every shape that touches the wind in the vehicle.
The processing power that you can put to these problems now is just immense. We can load a full vehicle model into our simulation deck and run it on a web server and have results in 4 hours now.
Incredibly, the entire Aptera car has less aerodynamic drag than just one side view mirror that you'd find on an average American pickup truck. One aspect of the vehicle's design that often draws attention is the fact that it only has 3 wheels.
We determined that if we got rid of the rear wheel, one, we don't really give up any performance characteristics, but we gain in aerodynamics, we lose some weight from having the structure to hold that extra wheel, and we have less rolling resistance. So you have a certain amount of weight that's deforming the tire constantly on every revolution that you ever drive. So if you can decrease the amount of traction patch on the road, you get better overall efficiency.
Our vehicle can go around the track as comfortably and as securely as any comparable 4-wheel vehicle.
And one thing crucial to its stability is its center of gravity, which is greatly helped by the choice of powertrain.
How we power the vehicle is actually through the wheels. The motors are designed into the wheels. It takes the weight and puts it out at the corner of the vehicle, so you have a better center of gravity, which gives you more torque, so you get better 0 to 60 time acceleration, and it gives you more regen capabilities, so it saves your brakes and gives you better overall performance. Weight is crucially important to our efficiency, so the more we can reduce weight, the better.
And one of the heaviest parts of an electric vehicle is the battery.
Well, batteries are the most expensive part of the electric vehicle. And so if we can fundamentally reduce the number of batteries necessary to go from point A to point B compared to any other electric vehicle, then we're able to offer something that costs less to make and costs less to sell.
The combination of less weight, reduced rolling resistance, and world-leading aerodynamics means you need less energy to power it.
With 100 watt-hours per mile energy usage, you can do things like charge with a regular extension cord from your garage. The same cable that you charge your cell phone with is a cable that you can charge the Aptera with up to 200 miles overnight. Also, if you're on a trip and you go to one of the roadside chargers, you're charging 4 or 5 times faster than any EV around you.
But the Aptera has one more energy-saving trick up its sleeve: its solar-powered charging capability. All the more pertinent given the US Department of Energy's predictions that electricity consumption is set to increase by as much as 38% by 2050, in large part because of electric vehicles.
We have a 700-watt solar panel on our roof, and that can produce over 4 kilowatt hours of power per day in sunnier places. That's 40 miles of free driving per day just because you parked it out in the sun.
But for most Americans that drive less than 40 miles a day, 60 kilometers or so, you wouldn't have to plug it in. And the reason why it's even feasible is because the vehicle is so efficient. So if you were a big electric truck manufacturer or sedan with lots of batteries, you could cover the whole thing in solar and you might get 5 or 10 miles of trickle charge. Whereas if you can account for most of the daily miles from the sun without taxing the grid at all, then it makes it much easier to deploy electric vehicles across a wide area.
It really is just striving to build the best production vehicle we can for the people that have reservations out there.
Possibly the biggest changes this automotive revolution will have on our way of life will be felt in our cities. Michael Hurwitz understands the task ahead more than most. He worked for the British government, where he was the most senior official responsible for energy and transport. He then spent 5 years as Director of Innovation at Transport for London, one of the largest transport authorities in the world, responsible for managing the city's public transport network, which includes 9,300 buses, an underground system handling 5 million journeys per day, and main roads with over 6,000 sets of traffic lights. He now works for Arrival, one of the new generation of automotive companies that are bringing a fresh perspective to introducing electric vehicles into our towns and cities.
It is now absolutely certain that around the world, cities, regulators national governments are going to require an increasingly rapid shift to zero emission. Mostly electric, some keep an open mind to things like hydrogen, but it is happening, and it's happening at an increasing pace. There's an interesting point about whether the incumbent industry, the traditional automakers, can transition fast enough. Some people aren't as ready, but we feel that we're kind of ahead of the curve there.
When Denis Svedlov decided to found Arrival, it was because he felt it was not just the type of vehicles that needed changing, but the entire auto manufacturing model.
That is not enough, because we still get vehicles which are expensive and that's not sustainable. You don't need to have a compromise between being green or being efficient. And that's why we started Arrival in January 2015 with the idea to reinvent the way vehicles are made.
But where to start? Well, for Denis and his team, one particular sector above all stood out: commercial vehicles.
These are the vehicles that are being driven 8-10 hours, day after day after day. If there are any vehicles in a city that you'd want to replace with zero-emission vehicles, it would be these commercial vehicles.
One of the aims of Arrival is to be able to work with companies and create a bespoke vehicle specifically targeted to their needs, which is exactly what they've been doing with UPS, with whom they have jointly been developing a new delivery van. But how will this new startup company compete on price with established automotive giants who spent over a century mastering the production line and economies of scale?
I think the real opportunity with a startup, with a new company, is you don't have any of those existing assets. You can set off in a completely new direction.
The approach that Arrival has taken can in many ways be encapsulated by the words of the influential 20th century economist Ernst Friedrich Schumacher.
He wrote something along the lines of, "Any intelligent fool can make things bigger and more complicated, but it takes a lot of courage to move in the opposite direction." I love this quote. It really captures our DNA, what we do here, how we develop things.
Large automobile factories can take years to build and have a price tag of over $1 billion. Arrival believe that for just $50 million, they can take over an existing warehouse and within 6 months be able to produce 10,000 vehicles a year. Able to be built all over the world in locations where the vehicles are needed, they will employ local people, pay local taxes, require less infrastructure, and be able to provide specific models suitable to that location. They call it a microfactory, which instead of housing a conventional production line, uses a collection of robotic cells.
And we have a whole array of these cells that do different operations. But the key to it is how we link them together. We link them together through mobile robotics. So literally a little wheeled robot that carries parts and vehicles from cell to cell.
I've been building robots since I was a kid, right? From toys. I was fascinated with robots. I was fascinated with the spacecraft. So all my studies over the years were focused on this: space exploration, robotics, and AI. I met Denis after having worked on a space mission for the European Space Agency. We discussed about how to use technology to have a positive impact on people. And we liked each other, and I jumped on board. I left the space program and I joined Arrival.
Where once in the traditional automotive industry, it was tool makers who were crucial for the implementation of mass production, today a different type of engineer is at the heart of this new way of building vehicles.
More than half of our people are software engineers. We are strongly software people. What this means is that we spread intelligence in every robotic asset that we have on the shop floor. These robots sense and perceive the environment. They gather the data, they process it in real time, and they use this data to execute operations in real time. If something changes in the environment, they react. And then we have an operation control system. You may think about it as the overlord of the factory, right? The AI that runs it. And this system gathers continuously information from all the children, from all the robotic assets on the shop floor. We have done a lot of work on computer vision, and we've developed something quite unique. And our systems are capable of understanding the position of an object, classifying that object, understanding the position in 6 degrees of freedom, so in space, in any location, a sub-millimeter accuracy. These are robots that can navigate autonomously in the environment, can avoid obstacles, can detect any anomalies in the environment, and can react dynamically. And also work together. These robots can connect to each other to create a larger platform that can transfer bigger and larger payloads.
But as clever and sophisticated as the system is, if the microfactory concept is going to work, it'll need the right materials to work with.
I'm going to be a bit biased here, in that I think materials are like foundational to a lot of this. If you're going to manufacture something anywhere in the world, then you can go one of two routes. You can either source in one place and transport it, or you source close to where you're making. And our strategy is very much to try and source as close as we can to the factories to support local communities, local economies, and to build relationships in those areas. So if we want to be able to build a microfactory anywhere, on a high street, in a warehouse, you have to start asking questions about the kind of materials that are going to go into the factories. They also have to be recyclable, because you need to be able to reprocess them wherever you are. You know, if a van's built in one part of the world, it should be recycled wherever it ends up. And that drives a certain type of materials logic.
In order to meet all these criteria, it was decided to use an aluminium chassis onto which would be put a body made from thermoplastic composites. Able to be molded into shapes when heated, thermoplastic composites differ to many other forms of composites because it's a process that can be reversed and repeated many times, making it perfect for recycling and giving the product an almost indefinite shelf life.
It's where there is a huge amount of innovation in the industry. And we can process that by 3D printing, so we can make prototypes. We can turn it into injection molded components. We can process it into compression molded or extruded, or you can, make garments from thermoplastic materials. Like, it's just, the amount of opportunity of thermoplastics is just immense.
The company have developed their own composites, tailor-made for their requirements. Those destined for body panels arrive at the factory in the form of rolls of fabric. These are cut to size, layered, and molded into a variety of different shapes, and all done autonomously, using far less machinery and energy than a conventional automotive plant. And what's more, waste is eliminated because the properties of the material allow any offcuts to be recycled and made into other components.
Like, that's so fundamentally different from the conventional way of working. I mean, when people join the company, they often, it's quite mind-blowing. We are weaving fabrics and knitting, and there is no paint. The colour is throughout the panel, and you can recycle the whole panel at the end of its life.
Panels are also able to withstand impacts in a way that no steel equivalent ever could. All of which is of considerable appeal to commercial fleet operators.
Their vehicles are their brand that's rolling around in those communities day after day, so they always want their vehicles to look their best. They spend an enormous amount of money every year per vehicle to keep their vehicles looking so good.
This combination of versatile materials and a highly agile production process is also changing the way the company approaches its research and development.
So in regular R&D, I'm used to working on projects that are 2 to 4 years long. And here we're expected to turn around proof of concepts in a matter of weeks. If it takes longer than a month, then it gives us pause for thought. The point is to prove your idea as quickly as you can. And then that means that you can cycle through ideas much quicker. So the other core concept for us is that failure is not a bad thing. I encourage my team to fail as often as they can because, it's only when you fail that you either discard an idea and move on, or, you keep learning.
This ability to utilize the AI software to transpose concepts into production has enabled the team not only to develop commercial vans, but also buses and rideshare vehicles. With a growing list of customers, Arrival has already set up 1 microfactory in the UK and 2 others in the US, with more planned for other countries in the pipeline.
In hindsight, some of the most revolutionary ideas seem obvious. And I wonder if people will talk about microfactories that way in a few years, for instance. I can't explain exactly why nobody's thought of it before, but it is clear that bringing together the right group of people on the right mission with the right set of objectives was an important part of developing this very different approach.
There are still many challenges that need to be overcome to successfully make the transition to full use of electric vehicles. Today, over half the world's population live in urban areas. In Europe, it's almost 3/4, and in North America, it's higher still at 82%. And these figures are only set to increase. Many towns and cities have road layouts that are hundreds of years old, meaning space for charging is at a premium. It's sobering to consider that 40% of Americans do not live in a home where they can use a personal charger. So while some have been tackling the issue of electric vehicles themselves, others have been wrestling with the problem of how to charge them. Back in 2012, the founders of Electrion, a Tel Aviv-based company, decided to investigate the possibility of creating a viable wireless system known as induction charging.
So we have one coil that we put under the asphalt, and we have another coil that we installed at the bottom of the vehicle, and actually we have a transformer. This is something that was found by Tesla 100 years ago, and we are using this phenomenon.
To fully understand how the system works, one needs to travel even further back to Michael Faraday's work on electromotive force. He discovered that in the presence of an alternating magnetic field, an electromotive force could be produced across an electric conductor. Nikola Tesla took this a stage further. He deduced that if an alternating current was passed through a coil, it would generate an alternating magnetic field. If a receiver coil was then placed nearby, this alternating magnetic field would induce an electrical current in the receiver coil. And if you have an electric current, it can be used to charge a battery. It was a brilliant concept, but sadly, at the time, there were no commercial applications. It would take another century for the principle to be adopted by charging devices in our homes. But for the system to be viable for large-scale vehicle use, it would need to be made much more efficient. When they started, it was estimated that almost half the electricity would be lost during the wireless transfer. But the team were confident that by fine-tuning all the various components, as well as the power levels and oscillation frequency, this could be dramatically improved.
So first, when we established the company, we focused on dynamic wireless charging or electric road system. It means that we electrify the road and we charge the vehicle while the vehicle is in motion.
So this device is part of the R&D work. You can see here that this simulates actual vehicle driving on the road and being charged while driving. So those are the coils that are under the asphalt, and this is the receiver that is under the vehicle. Those coils are deployed under the asphalt about 8 to 10 centimeters. The coils emit energy to those receivers only when there's an authorized receiver that communicates with the coil, and then the energy is being delivered. Otherwise, those coils are totally passive.
So as a general rule, our wireless charging technology charges at approximately the same speed as any standard conductive charging solution that you can buy and use at home.
Having developed the theory, they built a 300-meter test track where they spent 3 years testing a variety of vehicles and perfecting the system to a point where it achieves an energy transfer efficiency of up to 91% in test conditions. They also perfected the system to charge static and parked vehicles.
It can be installed in locations where conductive or plug-in charging cannot be. So locations like bus stations and garages, inside city centers, underneath taxi queues or stands, directly under the loading docks at commercial facilities, and of course roads and street parking, for example, because there's no interference with the pavement or with the road. You know, everything can be underground.
With the ability to charge both moving and stationary vehicles, the next step was to put it into practice in the real world.
In Tel Aviv and in Karlsruhe in Germany, we have a public pilot on the roads there with the public bus operator in the city. And in both instances, we're demonstrating that with a combination of stationary charging at the terminal or at the bus station for a few minutes while the vehicle is parked, plus some small stretch of dynamic wireless charging along the route of the bus, is enough to power the vehicles so that they can run 24/7, and we can simultaneously reduce the size of the battery or the capacity of the batteries.
And it's this ability to reduce battery size that could be hugely significant as the number of electric vehicles on our roads increases.
There are about 1.4 billion vehicles on our roads today globally. We just haven't found all of the resources that we require in order to shift to electric mobility on a global scale. There are issues around destroying habitats, for example, from mining for cobalt or for lithium ion. And so anything that we could do to minimize the impacts and to minimize the size of the batteries is probably going to be a good thing. In theory, we can reduce battery capacity by up to 90% as long as we have wireless charging in convenient and accessible locations.
In Gotland, Sweden, they are already successfully operating the world's longest continuous electric road system, stretching over 1.6 kilometers. It charges not only a public bus at the moment, but also a 40-ton truck. What's so significant about this trial is that it demonstrates the ability to simultaneously charge different-sized vehicles with different energy requirements.
The system is totally automatic, so the driver actually doesn't need to do anything, he just needs to drive. We have a metering device inside the vehicles, so this is how we know exactly how much energy every vehicle consumes.
Each 100-meter section contains 60 charging units, each able to charge an individual vehicle, meaning that volume of traffic will not be an issue. It is hoped that in Europe alone, there could be at least 14,000 kilometers of such roads by 2030. But what sort of disruption would installing such a network cause?
Of course, we're not suggesting that we would come into any city and tear up all the roads in the city. We're looking at finding strategic locations where it makes sense to deploy because you have enough heavy traffic. So if you looked at a city grid, for example, you'd be looking at deploying somewhere between 15 to 30% of the main roads.
If deployed at scale, the team estimate the costs to be around $650,000 per kilometer.
When we established the company, we had a mission to deploy 1 kilometer within 1 day. And actually, it was a joke 9 years ago. But today, we can show that we did it twice, in Tel Aviv and in Sweden. Our goal is to pave a whole city in few weeks. And we are talking about a huge infrastructure project. And to do it in few weeks is a huge challenge, but I believe that we will reach that goal.
I think everyone has to accept a bit of change. It's a deep-seated connection to a personal vehicle that many people have. Many of us are going to have to let that go.
Without question, our relationship with the car and car ownership is about to change. But will it necessarily be a bad thing? In the United States, the country most synonymous with the car, over 10 million households already don't have access to one. And when combustion engines are finally phased out, will there be enough used electric vehicles available at a price people can afford?
Who is buying new cars? Who can afford new cars? Around the world, the average age of the car has been going up. It used to be around 9 years, and now it crept to 10, 11, now it's up to 12. The average age of new car owner is 52 to 54 years old around the world. Also, the economic burden on us is phenomenal. On average, and I was looking at these numbers in countries around the world, on average, it's about 15% of a household's budget is spent on their car. And that means when you go to work, the first hour and a half of your work is paying off how you get to and from work. Poorest 20% of us, it's 33% of their household budgets go to their car. And I was just seeing a study of the US that had counties highlighted, and there were some counties in which 80% of a person's income paid for their car. It's mind-boggling.
So when I was at Transport for London, you get to see day to day what is required to keep a city moving, and that's from the coordination of traffic, buses, the underground, ticketing, the cycle hire, overground rails. But one of the most fundamental questions is, how do you make what you provide work for everybody?
Many believe that by engineering our cities to work differently, we can create a sustainable, flexible, affordable, and convenient way to move about. It's called a multimodal model, which includes improving public transport, creating a safe environment in which to walk and cycle, and where the new electric micro-vehicles can fulfill those short solo journeys we now make in our cars.
How do you want your city to feel? How do you want it to look? How do you want it to sound? And from that, derive how you should behave in a city.
In many European cities today, and in the US increasingly, there's been this idea of the 15-minute city, which means that in my daily life, I will be able to walk or bike or go by subway in 15 minutes to get everything I need in my daily life.
But what about those times when only a car will do?
We do need cars sometimes. I am not anti-car. I have my 96-year-old mother. I am carrying lumber around. I have places to go that are far away. But it's not the thing that I want to own and use for every trip. The economic efficiency of not owning your own car is profound.
With concerns being raised about the embodied energy and the carbon footprint of electric vehicle production, particularly with regards to certain giga-scale battery manufacturing, could shared ownership be part of the solution? The notion of car share is well established, but how do you persuade people who are wedded to the convenience of having their own car to use them? Could autonomous cars that deliver themselves to your door be the answer? And just how good would the technology need to be? Not content with reinventing the factory, Arrival are also pushing AI technology in cars to a whole new level.
Hi, my name is Max Kumskoy. I'm a product lead of autonomous driving team at Arrival.
Max and his team are developing what is known as a full-stack autonomous driving system. A system which can operate without the need for maps or GPS tracking. A system that will rely on what it sees and senses. Autonomous vehicles typically rely on a range of sensors, including radar, LiDAR, which is similar to radar but instead of radio waves detects reflected light, ultrasound, and cameras to be able to see things like road signs. From all this information, onboard computers are able to generate a 3D model of the vehicle's environment. And all of this has to happen and be processed in real time.
You think, all right, you're good. But how do you know that you're good? You need to test yourself against somebody who is already recognized as a top performer.
RoboRace was a championship started by Arrival's founder, Denis Fedlov, which allows AI teams from around the world to compete against each other to achieve the fastest lap. But for Max and his colleagues, this just wasn't challenging enough. In Rome in 2016, the Arrival team took on the American professional drifter Ryan Turk.
And we saw the time, and it was just a disaster. The gap was just, unbelievable. We were like, well, we can do better. Because actually, computer has lots of advantages over human. And we were like, why are we not using it? What was just a fun bet now turned into a massive development of vehicle stabilization algorithms for autonomous cars.
They developed a series of algorithms to perform different roles. One to perceive the surrounding environment, including other potential road users. Another to determine which route or path to take. One for what speed to go, and one to actually control the car.
But that's not it. So you start driving, you are in motion, you're driving, and then, life happens. There can be a sharp corner, so your car can get out of control. So you need to have another algorithm that will actually detect that you are about to crash or about to do something dangerous and prevent or save the car from the situation.
When it came to testing their improved AI system, they decided to take things to a whole new level. Lucas de Grassi has been racing since he was 10 years old. Having graduated from Formula One, he went on to become one of the co-founders of Formula E and is now the most successful driver on the Formula E grid.
I think here the team has a big chance of performing really well. I hope I can still beat it, but deeply I want the team to be very, very fast.
The car was doing its best, but it wasn't changing its performance from lap to lap. And we saw that the gap with Lucas or with Ryan was huge. And we thought, all right, what is he doing that we are not? And we realized that he's actually learning. He is learning and adjusting from lap to lap. And that's when we implemented an additional algorithm that was learning. And that's when the car started to be faster from lap to lap. So it was taking into account everything it knew about the track from lap 1 to lap 2. Where can it go faster? Where can it go slower? That was a major point in our racing career. The car started to learn, and it was getting closer and closer to a human driver.
By analyzing all the performance data, the AI system can work out what it does differently each time, and if it makes it go faster. It then changes its driving behavior to reflect what it believes is the most efficient method. And over time, it's able to perfect this. By mid-2020, there was a palpable sense within the motor racing world that racing drivers were about to suffer the same fate as chess grandmasters.
First of all, I have 25 years of experience, while the AI have only like 2 or 3 years. So that's a bit unfair. But we are both controlling the car in the same fashion. So you have only access to steering, throttle, brake, and you have to combine these 3 inputs to create the best lap time around the track.
It was time to test the new learning algorithm. Would it provide the extra edge needed to outperform Lucas? But just when it looked like a breakthrough was possible, Mother Nature intervened.
So I had a lot of fun out there. The problem is that there are patches of dry and wet. So some corners, the optimal line is where it's a little bit more dry.
Launching in 3, 2, 1.
The conditions haven't improved, and the autonomous car's new systems will be tested to the limit.
Whoa. And now it starts to rain again, so it's very hard to compare now.
Yes, good effort. That was amazing. I've never seen it correct like that before.
The autonomous car is definitely improving. But has it done enough to beat Lucas? Who knows whether the car could have won without the rain? But the team believe it's just a matter of time. The ultimate challenge for Arrival and for their robo-race team is to make the autonomous car smarter than a human.
You can spend a lot of time to teach one human how to drive fast and safe. You can spend a lot of money on his entire racing career. That will be one guy. How do you copy that knowledge to the rest of us? You can't, right? With the computer application, it's different. You take all the bits, all the knowledge from those guys, you put it to the code, and then you copy this code to all the cars. That's essentially what we're doing. We're learning from them, putting it to the code, put the code to car, and copy.
This is so important. This is so breakthrough from Arrival, from RoboRace. In a couple of years, the world will look back at what we are doing today as something that pushed this technology that eventually will change a little bit the world for a better, safer place in the future.
Autonomous vehicles are currently being trialed all over the world. Companies such as Zoox have created rideshare versions. Taxis and buses are also being intensively tested, and in certain cities, they are even being integrated into the public transport network. Looking into the future, some envisage AI technology being used on a grand scale to coordinate citywide traffic flow, with technology optimizing speeds and the changing of traffic signals.
Done well, I think autonomous vehicles are a spectacular addition to a multimodal lifestyle, but we have to make sure that we do not own those vehicles.
The concerns over privately owned vehicles is centered around their potential to actually make congestion worse.
With an autonomous vehicle, I don't need to park. Please let me out. You just keep circling. I don't care what you do. Doesn't bother me because it's going to cost me nothing. I'll have my tea. I'll chat with my friend for an extra hour, and you come back when I call you. So that's hell. Heaven. So this transition to autonomous vehicles also comes with fitting into our multimodal lifestyle, where I can now have shared cars everywhere, even for people who live in rural places.
And then there's the issue of how us humans will react to seeing empty vehicles driving along on their way to pick up passengers. Will normal driving courtesies still be observed?
Yeah, that's a really big, so far unanswered question, right? Are people going to be kind to them? I think there's going to have to be a lot of work done to make people comfortable with the concept.
Our roadmap for achieving the electric dream may not yet be fully formed, but it is without question a journey full of opportunities, provided we have the courage to grasp them.
So when I was in central government, we were really challenging the industry to transform, to reduce emissions levels actually across Europe. And there was a lot of pushback from the auto industry, and a wise old civil servant, actually who I was taking over from in that role, took me to one side and said, don't worry, because engineers are brilliant. And human ingenuity and human creativity is the most tremendous power. And if you set a target and a goal, things that you never thought possible become possible. And it's great now to be involved in an environment where there's all of those brilliant engineering types, and we're going to see how far we can push it together.
Like no other time in history have we been at a moment where we can make such a clean and delightful break from poor choices of the past. I think we have to focus on that and say, I'm willing to make the shift, and if we don't address climate change, we know what our destiny is. This one Earth that we have is it. This is it.